Welcome to this explainer. I want you to think for a second about what happened the last time you ordered a package online, or, even just flipped a light switch and expected the room to instantly light up. Behind those simple, everyday actions is this massive, incredibly complex hidden world. Today, we're going to look right past all those dense corporate acronyms and uncover the actual living systems that power modern enterprises. We hear this term, IT/OT convergence, thrown around a lot in boardrooms, right? But to really grasp what it means, we need to look at what happens when the digital world collides directly with the physical one. And I promise you, by the end of our time together, you're going to see modern organizations in a completely new way.
Okay, let's dive into this. Here's our clear roadmap for today. We'll start by meeting IT and OT, pit information against physical reality, explore the convergence loop, weigh the price of connection, and then finally, look at the new enterprise system.
Part 1. Meet IT and OT, two completely distinct worlds.
So, for a really long time, these two systems lived in entirely separate realms, both literally and figuratively. To understand why they're converging now, we have to understand their core identities first. It helps to think of this through a biological analogy. Information technology, or IT, is basically the nervous system of an organization. It's your emails, the cloud servers, the business software. It carries the signals, right? Operational technology, or OT, on the other hand, acts as the muscles, the joints, and the physical senses. OT is the robotic arms swinging on an assembly line, the pressure valves in an oil refinery, or the massive cooling systems humming away inside a data center. It's the stuff that actually makes things happen out in the real world.
If you take away absolutely nothing else from this explainer, let it be this. IT moves information, OT moves the physical world. Just let that sink in for a second. Because once you truly feel the weight of that difference, the whole concept of convergence begins to make perfect sense. It's not about one side suddenly replacing the other. I mean, you can't have a functioning body with just nerves and no muscles, right? And muscles without nerves are totally useless. It's about how a modern enterprise absolutely relies on both of them to survive.
Moving to part 2. Information versus physical reality and their different languages of success.
Because they do entirely different jobs, their priorities radically diverge. IT systems are built to adapt. They're optimized for flexibility, scale, and the speed of change. If a business needs a new app, IT can just build it without rebuilding the whole world. But OT? OT is built for absolute stability. It values safety, reliability, and real-time response above everything else. And why is that? Well, because the physical world is incredibly unforgiving. Look, if an IT system fails, maybe an email doesn't send, or you just have to turn the app off and on again. It's frustrating, sure, but it's fine. But if an OT system fails, a one-ton robotic arm swings the wrong way, a chemical vat overflows, or a power grid overloads. The stakes are physical, and they are immediate.
And this brilliantly illustrates the divide. Think of it like a recipe book versus a stove. IT is your recipe book. It stores instructions, scales beautifully, and coordinates what should happen. You can cross out and rewrite a recipe 10 times over, and you're never going to burn anything in your kitchen. But OT is the stove. It produces the actual heat and creates the physical result. Changing the stove at the wrong moment or rebooting it while you're in the middle of cooking, that has immediate and potentially dangerous consequences. Which brings us to what's probably the most important mental model of our entire explainer. IT works with representations, OT works with reality. Updating a row in a digital spreadsheet is just manipulating a representation of a shipment. It's totally abstract, but physically stopping a spinning turbine, opening a high-pressure valve, or halting a massive cutting machine, that is reality. The laws of physics apply. Momentum, heat, gravity, they literally don't care about your software update.
You can also think of IT as the map, and OT as the city itself. You can redraw a map on your computer screen in a matter of seconds, but you obviously cannot rebuild a city block that fast. The map helps you navigate, but it isn't the concrete under your feet. Now, convergence is exactly what happens when the map starts directly influencing the city. Imagine if drawing a new road on your digital map instantly caused bulldozers to start pouring asphalt in the real world. And the moment a real-world traffic jam happened, the map autonomously redrew itself. That is convergence.
Part 3. The convergence loop and moving from two separate stacks to one.
So let's look at what actually happens when these traditional two stacks synthesize. In the old model, these worlds were fiercely separated. An engineer would literally walk a factory floor with a physical clipboard, write down machine temperatures, and then someone would manually type them into a computer hours later. OT ran the process and eventually passed a delayed report up to IT. Well, convergence turns this disconnected vertical stack into a continuous, living loop. Live signals completely replace delayed reports. Decisions are suddenly being made with way fresher data and a much richer context.
That manual translation just vanishes. The entire enterprise stops waiting around for end-of-day summaries and starts acting on exactly what the plant floor is doing right at this very second.
So the crucial point is this. A traditional setup basically acts like a mirror. It only shows you what has already happened, way after you can do anything to fix it. Convergence turns that passive mirror into an active conversation. It's the difference between finding out a machine broke yesterday versus having a dialogue where a machine whispers that its vibration patterns are just slightly off, which lets you order a replacement part before it ever actually breaks. It turns passive observation into a predictive, active dialogue across the entire business.
All right, part 4, the price of connection. Let's weigh the trade-offs.
Because as you might guess, connecting these systems isn't just some magical upgrade. Connection introduces a powerful but incredibly challenging concept known as coupling. Coupling means two systems become inextricably dependent on one another. Yes, they share incredible coordination capabilities, absolutely, but they also share operational risk. If a hacker manages to get into an IT system, maybe through a simple phishing email that compromises a billing portal, coupling means they might now have a digital pathway to shut down a physical oil pipeline or a factory floor. We're merging the pure flexibility of IT with the physical stakes of OT, and that creates this intense, inherent tension.
Now, what's really interesting about this slide is looking at both sides of the ledger. We gain incredible things, right? Wildly faster decisions, complete end-to-end visibility, and operations so efficient they almost seem magical. But look at the cost. The complexity completely skyrockets. You have deeply shared risk. And most importantly, notice that concept of the blast radius. In the past, if IT went down, the factory just kept humming along. If the factory stopped, IT could still process payroll. Now, the blast radius of a failure in one system can instantly cripple the other. Gaining all this incredible operational convenience means actively losing the safety net of isolation.
It's literally like opening a door between two rooms that used to be safely, blissfully locked away from each other. And because of this newly opened door, ownership changes completely. Imagine a connected sensor on a machine breaks. Whose job is it to fix it? Is it the IT network engineer who manages the data flow, or the OT mechanic who normally turns the wrenches on that specific machine? If those handoffs aren't crystal clear, what starts as a simple technical glitch rapidly devolves into a massive organizational turf war.
Finally, part 5, the new enterprise system, showing reality in action. Let's ground all this theory in a high-stakes, real-world scenario. Imagine a temperature-sensitive logistics operation in the United Arab Emirates. It's 115 degrees outside, and a cold storage truck is carrying a shipment of vital, temperature-sensitive medicine. Historically, if the OT system detected a cooling problem, a little red light blinked on a dashboard. It was just a localized maintenance issue, and by the time anyone noticed, the medicine was completely ruined. But in our new Converged system, the exact second OT detects that temperature rising by even a fraction of a degree, it signals IT. IT immediately checks the database, flags the specific medicine shipments affected, automatically adjusts the delivery routing of nearby trucks to intercept the cargo, and empowers customer service teams to notify hospitals about a slightly delayed but completely safe delivery. A physical crisis and a business response move perfectly simultaneously.
Let's zoom out and see how this builds to our ultimate conclusion. The enterprise transforms into a system of systems. A machine generating data without a network to share it is isolated and blind. And data floating in a cloud without a physical machine to act upon. It's just abstract math. They can no longer exist independently. They absolutely must work as one single living organism. The true value isn't in the nervous system or the muscles alone anymore. It comes entirely from how beautifully these systems behave together.
So you can now see the hidden machinery of the modern organization. The line between IT and OT is no longer a brick wall. It's a deliberate design choice. As we weave our digital maps inextricably into our physical cities, the defining question of our time isn't whether these systems can talk. The real question is, how should they talk? What should they share? And what absolutely must remain safely protected behind a locked door? The next time you order a package or just turn on a light, think about the conversation happening between the map and the city to make it all possible. Thanks so much for joining me on this explainer.